All right.
All right. So, welcome everyone to our podcast for the Africa Deep Tech community. This is our fourth podcast, I believe, or fourth episode.
Yep.
And for us, every time we get to do this is like a gift because, when we started this podcast, we didn't know if the first one was going to be the last. But now we're on number 4. And so, we just take everyone as, we're really grateful every time we get to do this. And just as a reminder, the Africa Deep Tech community is focused on, as the name implies, deep tech. The definition that I like to use for deep tech is the one by Eric Redmond, that basically defines deep tech as innovations that push the boundaries of science and engineering and often involve substantial research and development. Right. So he even went further to say that technologies that were impossible yesterday are barely possible today, but tomorrow will be so pervasive that we can't even imagine how life existed without them. Right. And that's basically what we love to talk about on this podcast. Today, here with usual partner in crime, Zach, we want to welcome somebody who's really, really amazing. Every time I'm in the same room with her, I get smarter somehow. Really, really awesome to have her here. And want to welcome Omoju Miller. Welcome.
Thank you.
So I guess Omoju, let's meet you. What do you do? Who are you? What you about?
Okay. So I am a Nigerian living in Silicon Valley. I live in Oakland. I professionally am a startup founder. I'm a founder of Fimio.XYZ. And we want to create reproducible builds, make them very easy. I have just said so many things that you're just like, what is reproducible builds now? What's that one now? But give you a little bit of our background of how I decided that this is going to be my new obsession.
Yep.
I was part of first Internet 1.0. That was when I was in undergrad. I was super excited about it. And I wanted to be a computer scientist because I was just like, yay, this is amazing. This is what I want to do. And I was a computer scientist. I worked in the industry, part of the first boom and bust, and then went and did my PhD at Berkeley in computer science education, but mostly like a cognitive science type PhD. Well, before I even did that, I was a researcher at the University of Memphis doing research on sensor fusion, sensor integration. And what we wanted to do was knowledge reasoning systems, expert systems that would do plausible inference by integrating all the knowledge of the sensors together and tell us what's happening in the environment. And I was actually good at this thing, but I did not know what I was doing it for. It was just like, research. But one thing led to the next, and my research started pinching me small. I started feeling uncomfortable because I was like, okay, we're funded by the Department of Defense. I was very excited about that. Now our stuff is real. And then one day I was just like, wait, these images that we're getting, what is going on in these images? This unmanned aerial vehicle, I think it's a drone. I think this drone is a weapon. I have these pictures. I'm like, this is an object of war. And I started feeling very uncomfortable about it because I hadn't quite made my decision. I was just trying to do some kind of symbolic artificial intelligence. I wasn't really thinking about the applications of any of these things at all. And I started feeling uncomfortable, so I stopped that. Went away for 4 years to be a stay-at-home mom, complete career pivot. Did that, then came back. I was like, okay, what am I actually going to do? I was like, you know what? I love my AI stuff. I love reasoning. I love learning. I want to continue doing this, but in a different context. Education. Can we use data to actually improve how people learn? And not just learn stuff because they want to learn knowledge, but learn technical material. Because I felt like, if you really knew technical material, it could change the world. That's why I came to Berkeley. I did this PhD in computer science education. And this was the era of MOOCs and all this, the first MOOCs just came out. edX, Coursera, Udacity. It felt like I was prescient, that I was going to exactly where this puck was skating to, and everything just came together at the same time. When I finished, I was like, I'm going to do this, continue doing this, but now let's actually bring back AI to just aid small learning systems. Now let's do it in an informal learning environment. Where do people go to actually create applications and write programs? Like we say, technical work is code. Where are they writing code? Where are they using all this stuff? GitHub. That is the place that all of them are going to. Would it be awesome if GitHub actually had some kind of AI systems built into that data to help all those developers achieve their goal just better, or even teach them or something like that? So that became my next goal. I went to GitHub, was an ML engineer at GitHub. Did some of the first ML stuff at GitHub. Our team, recommendation engines, Dependabot, all the security stuff. Then one of my colleagues did an amazing experiment. We called it semantic search, natural language search. It was like, oh, what if we could actually write some model, sequence to sequence model? I think that's what he did. Use natural language to actually search for code and bring up code snippets. And he did that experiment, and we were all like, this is amazing. You could just say English, I want to do this, and then some Python code will come up. One thing led to the other. Now, I'm working for the CEO, Nat Friedman. Nat bought GitHub on behalf of Microsoft. Then I became GitHub CEO. Now I'm working for Nat as his technical advisor. And now the world is even bigger. Now we have OpenAI. They have GPT-3 and all of that. And it's like, all right, so now all of these models can actually come together and do something rather powerful. But they need a distribution channel, and they really need a place where these things can really have power. And that channel became something like VS Code plus GitHub. So if we actually type in the most, you're probably typing in an IDE. So it becomes, let's deploy this in the context of an IDE and see how good this thing can be. So a developer is writing in English again, or some language, and code spits out. That became super successful. Starts the revolution of Gen AI, because it is a large language model. And it's in this context became super successful. Nat leaves, I leave. The question is, what's next? What do I do next? Now my dreams have actually come true. I wanted to use computers to help people learn technical material. Such an audacious dream, like one of these deep tech things about something you can only imagine, and we've all been looking for intelligent tutors and all this. And now we actually have something that is pretty good at doing that. So then what do you want to do next? If you have a dream and your dream comes true and you're still alive, what is there to live for? So you have to come up with another dream. So what is the next quest that I'm going to go on? And for me, it was open source. There's a whole lot. Even the reason why we can have all these LLMs is because we have all this open source data. We have all this data, and this data is open. And then there's this thing called Web3, which for me was like, this is the future of open source. Open source has a big problem with coordination. It's a coordination problem nightmare. Web3 is a permissionless system that could help with coordination problems. And the idea of a DAO felt like this could be some experiment in putting some kind of governance on open source. And maybe we can even invent new types of companies, start reading all these books and realizing that the limited liability company, all these things were invented. It wasn't like it just came from God. So then I was like, you know what? That's what I'm going to do. I'm going to go do a startup and work in that area. And that is what has led me from then to now to founding Fimio. And that is a quick, who are you?
Oh, man.
What are you doing?
Like, you just opened up like Pandora's box, because there's so many questions I have. Like, even like Zach, I'm sure I saw his ears prick up when you mentioned Web3, because I know that's something Zach is really, really excited about. Well, I'll start even like fundamentally, right? So behind you, there's a picture, right?
Which
of
ones?
somebody in that picture.
Well, there are many pictures.
Exactly, that one, right? And for those who are listening, who can see the video of the podcast, it's a picture of a little girl. In what I'll say is the stereotypical Nigerian living room of the 80s. How did it go from that little girl in that living room to being excited about Internet 1.0?
Yeah, so I was born in Lagos, Nigeria. one of the most exciting and psychotic cities in the world. And I went to a very, very good high school, St. John's College. That's what it was called. It no longer exists. But our proprietress was somebody who had visionary educator. And so she always brought all these visionary things into the school. And back then, this is 1995, 1994, 1993, she brought a computer. We had a computer in our little school library. So at least there was a computer there. The computer, it was there. And then she enforced, so if you do grow up in Nigeria, Nigerian high schools, they put you in a bucket from day one. And they put people in 3 buckets. The doctor people, these are the people who will do physics, chemistry, and biology.
Yep.
Those of us that can't do physics, chemistry, and biology, we are in the second bucket. They say it's business or something.
Social science, business, yep.
Then there's a third bucket. They call that art.
Art.
And the art, you don't want to be the art bucket because that's their way of saying you're going nowhere.
Yep.
The business bucket is, well, they're not quite losers, but they're not winners. And the first bucket is, these are the people we're going to put the future on. So I was in the second bucket. I wasn't quite a loser, but I wasn't quite a winner. I was just alive, just there. So we, the business people, by force, we had to do computer science. So I had computer science classes.
I'm guessing the computer science was like a substitute for typing and shorthand.
Exactly,
do,
because
right?
the classes don't make sense. Computer science, technical drawing, home economics, some of these things don't even belong together. But here we are. By force, we will do it. So at least I took the computer science class, which I hated with a passion. But it was mandatory. You have to do it. You have to do it. At least some information entered my head, and I don't want to get F, so I will pay attention small. But I was like, this makes no sense to me. But I can regurgitate some things back to you and satisfy some criteria, maybe get a B. I remember we were talking about registers. I was like, what? A register? CPU? What is this? This did not make any sense to me. It was too theoretical and it was too low level. I was just like, whatever. Fast forward, I come to America for my cousin's wedding. I have finished high school at this point, and all the universities in Nigeria are on strike. And my uncles and aunts were like, what? To my dad, why don't you let this kid stay here at the school in America? If they went back to Nigeria, there's no university they're going to. They're all on strike. Hey, we can take care of them. Let them stay. From wedding, decided we are staying here. We're not going back to Nigeria. And I was like, whoa, that's a shock. Think about that. It's like, wait, what? I didn't even say hi bye to my friends. What? And they were like, yes. And
Wait,
also,
sorry.
you're not staying in New York.
Sure?
You're moving to Memphis.
Are you sure the wedding was the actual reason why they came here?
The wedding was the reason because my dad did not want us to stay in America.
I'll move you to the US without your consent.
No, they hated America. They hated this country with a passion. They were more Anglophile. They were like England, the land of civilized people. America is the wild place with uncouth people. I mean, I love New York. I was like, hey, New York is giving everything that a city needs to give. I want to stay in New York. They were like, no, you're not staying in New York. You're going to Memphis. Like, what is Memphis? Elvis? I was like, wait, am I going to Bonanza or Gunsmoke? I don't know. I was so ignorant. Anyway, I find myself in Memphis. I have no choice. They say, you're going to school. You're going to school. Within 3 weeks, they were like, you have to take the ADTC and pass and get into school so you can change your, what is it, I-20 or something, and now become. Yeah. This went from 4 weeks to literally I was in the university. I had to take the exams. I had to pass. I had to do. This is insane and crazy. But I went to the university. The first university I went to was the HBCU, Lemoyne College. They had a mandatory computer class, not computer science. Just computer class. Everybody needs to know how to use a computer. This was like 1996. This school uses Microsoft Word, Microsoft this and that, writing and all this. We are not doing typewriter anymore. It's computer. So all of you must use computer. Okay, now this is the first time I'm really using the computer. In my high school, we had a computer, but only the boys used the computer, and we the girls were watching them over their shoulder.
Wow.
That was my experience with computers. But now I could sit in front of my own terminal and be typing. And of course, I discovered the internet. And I was like, wait, what? internet, endless information. I can just do all the research I want to do. And then one thing led to the other. I was like, hey, wait. There will be internet shopping. My brain was just like, e-commerce is going to exist. Because I was in Memphis, which was the hub of Federal Express. And I had worked with my dad for a year and a half before I even came to America. So I knew about, my father had a company and a factory and warehouse. And so I knew about logistics, I knew about container. I'm bringing container from overseas and, going to the wharf. I knew all about all that stuff. So I knew how goods came from a manufacturer and ended up on a shelf. And they've been in Memphis, the home of logistics, air logistics, air freight, FedEx. I was like, wait, do you have to have a physical store? All you need is inventory warehouse now. Put something on the internet, see if they can do credit cards, click. Show me the things for the outfit to come to your house. I was like, this thing is amazing. I think there will be internet shopping. I can do endless research. I'm being a computer science major. That was it. It wasn't like some deeper thought.
Yeah.
And I was like, it's computer science, or math or something. So I did the math. I was good at math. That wasn't a problem. But then algorithms, I was like, oh my God, thank God. This makes sense to me. I don't have to actually cram everything in my head. I just need to be able to read something and understand rules. I don't actually have to know the answer to anything. I don't need to know 12 times 6. I don't need to know the answer. But I need to know the rules. I press a button and to tell me. I was like, oh my God, this is my future. And I was happy. And then I transferred to the bigger university and became a computer scientist and even found out AI. And I've just been happy ever since. When something is designed and your brain just works that way, it was like, finally I can be useful for something.
Oh my goodness. So much to dig into. Zach, what are some of your thoughts or questions?
The path to picking computer science is pretty interesting. I think it's what you said about finally you find something that doesn't require you to memorize. You just have to understand a few rules and then you can extrapolate. I think that's a common thing between pretty much everyone in computer science. Because like we don't want to be bothered to read too much information, but at the same time we want to figure out how to access information faster.
Yes, I just want the rules and I want to reason. At least I have a brain.
Yeah.
Can I just reason? All this memory rubbish.
A friend of mine, way back when we were in university back in Nigeria, the way he explained it is one that really stuck with me. He used a Microsoft programming analogy. He said that there's the statically linked libraries and the dynamically linked libraries, right? Where one, you carry all your code around with you and you can't work without that code. But DLLs, you look around to see all the things I need in my environment.
Who's here? Are you here?
Who's here? What's going on, right? And then from there, you can be useful. Yeah, I always found myself to be more like a DLL kind of person than a static library. Interesting. So tell us more about Fimio. Like, what are you up to these days?
So we started off with, the whole thing was like, okay, Web3 is going to be very important, but it's not safe and it's reusable. If people get rogged all the time, this thing is just going to go away. So I can do some machine learning. Smart contract is good. We can find some vulnerabilities in code. Eventually, if you're going to get rogged, it's through this smart contract, right? That's the thing. And the thing is immutable. All right. Let's start writing some ML on code for smart contracts. How do I get the smart contracts? Maybe they put them on GitHub. Maybe they put them on Etherscan somewhere. And they start asking deeper questions. Where is this thing deployed? I remember one time I was sitting next to the guy that did the internet computer, Definity. And I was talking about Ethereum. Joe Lubin. The way he was talking about Ethereum, it's the internet computer. It's the internet computer. I did not know what he was talking about. What is this internet computer that Joe is going on and on about? But then I found myself actually doing Ethereum stuff and finally realizing, oh my God, this is a computer. It is literally a distributed computer that is all over the place. So now there's the Ethereum client, there are the nodes, they're syncing. People deploy these contracts to the blockchain. They are ran, they have results, and understanding that level of infrastructure of a distributed system and then downloading the Ethereum blockchain, always keeping up with the chain, unraveling the chain, trying to figure out all the different stuff that is happening, all of that stuff. We built this API. It worked fairly okay, but I shut it down in 6 weeks. I was like, actually, you know what? This was a bad idea. We're not doing this business. We're venture-backed. We've raised money. We owe it to our investors to actually not just be technology-led, but solve a problem that really, really existed. Here, at this point, 11, 12 years into Web3, the future is coming, the future coming, they're coming, they're coming. They have not come. And I could not lie to myself. I was like, I was around at the beginning of the first internet, really, when it came through, Netscape Navigator, that whole era. Within 10 years of that, the world has transformed. Major companies have been created that were not even used by technical people. Words like Google and all this stuff had become verbs, and people were using these things. We've had 11, 12 years since Bitcoin. That has not occurred. And then on top of that, SBF and all this stuff. And I was like, we are a small startup. I know what it takes to make this thing win, but we don't even have the pockets right now. We need to go toe-to-toe with government, with litigation, with lobbyists, with education, with every single thing. If I had $1 billion war chest, I could fight that fight and I will probably win. We don't have $1 billion. We have like 2 point something million. No. Stop. We're not doing this. We shut it down. Then the question is, what are we going to do? Do we return all the money back to our investors and say, this was a bad idea. Sorry. Oops. Take your change. Or do we go and find another quest that really actually matters? And one of our investors, Erica Brescia, who is at Red Point, she will always keep pushing me. Go think more about everything you learn in Web3. I'm sure there's something you can use. And I kept pushing more and more. And Fimio today is kind of doing almost the same thing, but for a very different purpose. In doing that machine learning on code, one thing that we had to do was write the models. Yes, we can do that. Was deploy the models to production. That was a far harder problem than I anticipated, because in the other times, I deployed models to production in GitHub, but GitHub had infrastructure teams, data engineering teams. They had all these teams that you could just go talk to that team. That team has written a tool or this, that. And yes, you have to deploy a model, but there are tools and teams behind that you could fall back on. You didn't have to do everything from scratch. We had to do everything from scratch. And I was like, yo, deploying models is not trivial, man. This stuff is hard. And when you finally get something to work in your local environment, and now we want to move to staging, everything will break. I'm like, my code has not changed. What has broken here? There's some stupid library underneath you that has changed, and just all these infrastructure things fighting with infrastructure. And I was like, you know what? There's got to be an easier way to do this thing. This does not make sense to me. And if this thing does not become very easy, that is the end of the open internet. Because the next evolution, open source, we're going to have open source models. We have open source models. What is the point of an open source model if you can't deploy it? It's like a waste of time. For the future to really be free and fair, it's bad enough that these things are expensive to train. All right, we can't win that war. But you should be able to deploy a model on GPU without breaking your neck. And you should be able to do it in a way that is safe and truly reproducible. Meaning that if you went back and did it again, nothing is going to change. There's no oopsies, surprise. It was working 3 weeks ago. I come back. What has changed? Why? This and that. And then you're spending 5 hours troubleshooting some nonsense. That has nothing to do with your code, but has all to do with infrastructure. So I said, wait, people, we can solve this problem. My team and I was like, we can solve this problem. If anybody can solve this, it is us. Why? We come from GitHub. All our work for Web3 has made us understand blockchain technology. And this is not about building a blockchain or anything like that. No, it's not. But Git itself, you could be looked at in a way as a blockchain, because to a certain level, it's an immutable data structure. It's the same Merkle trees, it's the same everything. The only difference is there's no coin, there's nothing. It can be distributed, it can be decentralized, and it has the history from now to Genesis. It's the whole thing. We know this thing deep down inside 365 ways. We can build something based on these kinds of technologies to go over processes. That's all we need. We need something that can give you the full visibility and full transparency of your build environment. If you have that, all this problem that we're always fighting to find what changed, figuring out what changed, all you need to do is diff your build environment. I know that logically in my brain. The question is, how do we do this? How do you capture everything from the build environment? How do we do all this? How do you make this thing trivial? And that's what we're working on now. We are building reproducible builds specifically with the goals of making sure that it's very easy with a few clicks to deploy your code to the cloud, especially if you're doing open source models. So it's Python first. All this work is around working with servers in Python easier. That's basically what Fimio is doing today. And this is not even rocket science per se, because other languages, JavaScript, already have this. The average JavaScript person just does their little thing. They use Netlify, they use Vercel, the thing works. They don't even have to really worry about deployment and dealing with all this kind of stuff, because the language affords that. The language has that build system built in. The average Python developer does not necessarily build code. Python is an interpreted language. They can use it as an interpreted thing in a REPL environment. They're writing algorithms to solve problems. They do build applications, but it's a different kind of application, but it's very server dependent because it has to be like pushed to some server. And then if you're working with GPUs, it's even more hardware dependent. So now it's not just software. You have to have some kind of nice marriage between hardware and software. And how do you keep track of all of that? And that's what makes it hard. Talk less of now if it's going to be on some multi-cluster situation. It's just... yeah, then you're just like, oh, screw it, I'm not doing this. But no, we have to continue fighting the fight. And we're going to build this. We have built it.
Yeah.
I'm very excited about that. We have built something that actually works. And now I'm looking for my design partners to help us actually troubleshoot it and test it in prod so we can work out all the kinks and then we can scale it and make it GA. That's what Fimio is doing right now.
Amazing. So just before I dig into the real question I wanted to ask, for the purpose of, I guess, people like me who are watching, who may not necessarily be machine learning experts or AI experts, but can relate to build and deploy from a standard
CI/CD
developer, CI/CD perspective, how would you describe Fimio to somebody who is from that world?
Fimio is Netlify or Vercel for Python. So we have the Jam stack, JavaScript, web development, the whole thing. And you write your little thing, you connect to this thing, boom, it's in production. You can see a preview build environment. You're like, yes, it looks like what I want. You kick it off. For Python, it's not as straightforward. Python, even me, who's an expert in this, there are questions I didn't ask myself until like 2 weeks ago. I was like, wait, what is the difference between a Python package and a Python application? Are they the same thing? They are not. So the average Python person is used to using libraries. You know, I mentioned your dynamically linked libraries. So the Python people use libraries. JavaScript people also use libraries. And they just do pip install. They install their libraries. JavaScript usually have some kind of JSON package lock that kind of helps manage dependencies. Not perfect, but, kind of something like that. Python does not have that. They have it, but it's not enforced. You can run a Python script from a terminal that will do something. That script will do something, will give you some answer. It's not quite an application because you can't deploy a script. A script needs an environment that it will work in, and you can repeat it, and it does one thing. That when it goes into all of that, becomes an application. And so that whole build process that is hidden from the average JavaScript person in full detail, you just do your npm build server, npm something, it does all that for you. In Python, you don't have to do that. You just write Python main.py. Something will happen. And then you don't worry about it because it's a language that wasn't designed for real rigorous applications. It was designed for hardcore math things. So the math people are not necessarily building math applications. They're solving some kind of search a star in this giant data sets. And they're doing advanced search at high levels. And all they need to do is find the answer. The answer might just be some longitude or latitude somewhere. Now, turning all of that into an application is bothersome.
Yeah.
And this is not shitting on Python. I love Python, but it wasn't invented for regular application type. There's Django, there's that. You can write applications in Python, but I don't think that's its reason there.
No, it's not. I think I can relate to what you're saying, right? Because I'm guessing the reason Python is now the default language for machine learning and all of that is scientists used it. It was easy to use to do all these things you talked about. And so it was natural for scientists and mathematicians to use it. And oh my goodness, by the way, this thing we actually did is something that like we ended up building a model that we need to now use over and over again, right? And so how do you take that thing? Yeah, I mean, it's even something, even me as a newbie Python person, like you're working on something on the Python command line, right? You've tried a number of commands and finally you get it. And you're now like, okay, I want to get all those commands I wrote as I was trying to figure this stuff out and turn that into a script that I run over and over again. So I'm guessing that's kind of how Python evolved into being what it is.
It came out, a lot of the Python libraries are very powerful that we all love are scientific Python, SciPy. That's what they came out of. These are things designed to do multiplication of matrices and tensors. That is what they are doing. You multiply this thing by this thing. And in the old days when I started doing AI work, there was no Python package. If you wanted to do tensor multiplication, you had to write everything from scratch. You write the entire multiplication tensor thing. Maybe some infinite for loop of 6 for loops inside each other based on, okay, IJ, okay, then JK, keeping all these things in your, figuring out. That, it will take you 2 weeks to even write that one. When you finally write it, then you can do the multiplication. So you can see how ridiculous that is. So if Python package exists that does tensor multiplication, all you have to do is just put it in and it does it. You're like, fantastic. And machine learning is multiplication over and over again of giant ass matrices. Well, that's what it is. It's like it's a search, hyperdimensional search space. So I never thought I would understand math like this, but now it's so intuitive. It's just like, oh, this is what it is. But now that's multiplication. Turns out that we can translate that and map that to do retrieval, and it's useful. And we can ask questions and do some mapping, this and that. It looks as if this part of this thing fired is close to this one that is close to what it looked like. And we spit it out, and then we humans are very smart. We fill in the blanks. It's useful. But now, everybody used to do this. The big people used to do it. Google used to do this. Amazon did it. It's not like they don't know how to do it. They know how to do it. And they did it very well. They hired people. But now this thing has become mainstream. Now you and I want to do this, and we're like, okay, we don't have 500 engineers. We don't have this. We don't have that. Clearly, there has to be something that's going to make it easier for us to do this. Fimio is part of that vanguard of let's normalize this. And then beyond just normalizing it, everybody should be writing their code in a way that is secure. Not just writing code everywhere, just writing stuff. No, security should be built into the tooling. You can't expect a developer to become a security expert. That's not going to happen. But this was one of the benefits truly from understanding how Git works and Web3. Web3 systems are actually quite permissionless and secure. It might seem weird to say that, but they are, because the attack patterns are humans. The humans and bad user interface and bad UX is what makes it easy. The things that happen in Web3, it's not fundamentally the fault of the technology. It's bad user interface. We're asking people to memorize keys that don't come naturally to them. This is some hexadecimal number that is 42 long. The average human being does not have a password manager. They don't even know all of the, where they're going to store this. Maybe they write it somewhere. Or a lot of people use the internet when I see my friends use the internet, I am stunned. The things that they do, I'm just like, wait, what? They have no idea of security. They're just using some keychain to save passport. They don't even know where all these things are. I'm just like, how are these people living their lives like this? But that's because they're not security conscious and they don't have to be. Code is one of the greatest places to exploit and attack systems and take control over systems. And the way we make sure that that's not going to happen is by actually the thing that we all use, that we all literally use. We don't use code, we use applications. The thing that we are literally touching that is doing something for us is an application. The build process of that application has to be fully secure. And the way to prove that it's fully secure is that it is completely reproducible. That means that if you build it twice under the same exact conditions, there will be no changes at all. You do the thing twice and you minus it, it should be equal to 0. That means nothing else has changed at all. That means that thing is fully secure because it can keep doing it 1,000 times. The input and output will always match. And we can use mathematics and cryptography for that. But now, pieces like Fimio, we are building it into the tool chain so that you can create a reproducible build without you having to be a security expert. And if that becomes the de facto way of how we actually do builds, we have conquered one big way of attack vector in the world. Without people even have to think about it. This is the way we do it.
Man. So you said you're looking for design partners. Who is the person that's watching this that should be like, I want to reach out to?
Routinely building things in Python and deploying them to prod. So anybody that is doing this routinely, weekly, daily, you're writing something, you're packaging it, you're managing your dependencies, you're moving it from your local environment to your staging, you're doing some testing, you're going from staging to prod, and you're doing this over and over again. I want to talk to you. I want to learn how you do it. I want to help you make it better. And my best customer would be the person that does that on a GPU. Because Fimio does advanced 21st century version control like we have never seen before. That goes all the way from Git down to the hardware level, down to, I will tell you what version of GPU driver and what chip ran your builds. So you never have to know. There's nothing complete transparency. Make it as open as possible or for you to understand what's actually happening in a way that is not overwhelming. And I also think our app is very delightful and fun. It reminds you of cupcakes and confetti. That matters too, because when you're dealing with hard stuff, having the thing look good and make you happy matters, because our world is a world of frustration. And I want to change your emotional relationship to, like, even when you're frustrated, you should be delighted, you know? Don't give up, because the thing is hard.
Wait. So, cupcakes and confetti versus DevOps work. Like, this is something that I haven't put the two together.
When Omoju builds something, I bring all of myself to it.
Oh my God. So wait, what does... So actually, that's a good question. What does good user interface mean in this world, right?
Easy.
Because people who are deploying, I'm thinking of like command line, lots of cryptic commands and messages and stuff like that.
Nothing should scare you.
Okay.
I used to be one of those people that used to be afraid of Emacs and Vim and Terminal, because I felt like I'll be trapped into this thing and now I can't come out. Am I going to have to unplug my computer because I am trapped?
Trapped in the shell.
I'm trapped in the shell. I can't come out. I'm like, why did I start this thing without knowing how to leave?
Everyone got jailed at least once on Emacs or Vim.
That is bad user design. Why should I have anxiety? Because I just want to change some little bash scripts. Why? Even till today, no. I'm just like, what is this thing now? Why? There's that little anxiety that just comes up. And I think maybe we technical people feel like we should win a prize for having to fight through our systems.
Yes.
Why are we fighting through our tools? The prize is building and solving problems for people, not fighting with Emacs and Vim and all this rubbish.
And I think this is a very good point, because it goes back to something you said earlier, which is, if your dreams become true, what do you live for? And I feel like technical people past a certain point just either start to invent problems to keep being distracted and keep having something to do, to exist for, or go down the stack in things that don't matter at all for their day-to-day productivity and just try to optimize it, because that's like yet another monster that you kind of like kill during your Dungeons and Dragons quest. So like there is, I think, a meta game for a lot of software engineers that basically go from I want tools to help me build software to I want to spend as much time as possible learning tools to help me build software.
No.
But so, there is now, I think, a new wave of software engineers that basically say no to that and want actually delightful experiences. And these are more, I think, well, at least like in my experience, they're more on the generalist side. They can do the entire stack and they enjoy actually building delightful experiences. I mean, part of the Soul's product at the end of the day is the soul of its creators. And if the
Yes.
tools that you use are rusty and old and don't bring you joy, you're not going to inject joy in the end product. The end product is going to be as bad and rusty and clunky as your Emacs or VM terminal. Sorry if someone uses that. It's a waste of time.
Like, and I saw that first pass in crypto.
Yes.
Web3
yes.
has
Yep.
a user interface, user experience
Because of this.
problem.
Because of this culture.
Yeah, like some of this stuff does not make sense. You want to put in serious money, millions and millions of dollars, and the user interface looks like a cartoon. It doesn't make you feel like it's going to be secure. These are all subtle ways of communicating to people.
Yeah.
There's a reason why banks have that Grecian architecture. It evokes something old and secure and enduring. It's just common sense. And I am pushing against that big, because also the world is changing so fast. We're going up and up the abstraction layer, which is great, but there can come a problem with going too far up the abstraction layer, that it's so abstracted that you don't even know what is going on underneath it. And if you deviate from their little paved path, everything breaks. So the challenge is managing complexity whilst creating simplicity in reasoning, which is hard to do. And I think the people who create great developer tools do that. They don't want to turn into an idiot where you don't want to see anything, but they don't want to overwhelm you with so much stuff that you lose the ability to reason and feel competent. So it's that threading that needle. And I hope that Fimio is doing a great job in that, and that we actually lead the way to show people how to design these kinds of products.
Out of curiosity, do you use linear at all?
No.
To manage? No. Okay. Because my theory about like this whole topic of design and how it's influencing products and how the tools themselves end up influencing end products is with the rise of two tools, Notion and Linear. They kind of re-injected this new wave of design. Developer tools should not be crappy.
Ugly.
It should not be like a Jira type experience. It should make you happy to actually use a tool, because like using a tool is already overhead. And so like let's make that overhead as little as possible and not get in the way, as opposed to kind of like force our ways into your day.
The tools matter. The design of the tools matter a lot, because they themselves are gatekeeping. And you're right, Zach, the overhead. Your tools should be intuitive. You should even know that you're learning something. Or there's a tool I started using, Superhuman, for my email. I love Superhuman. It has been my true productivity hack. It is beautiful. It is sublime. It is simple. And when you get stuck, there is no fear of being stuck in the shell. You can reach out to a human being that will jump on Zoom and unstick you. I think that's also the secret hack. Human beings. I don't want to talk to an AI system.
Yeah.
I want to talk to a human being.
Or a big megacorp, because
they don't
you
even
can't
have phone
reach
numbers.
anybody.
You will never find them. They don't want to talk to
and
you.
even if you get the phone numbers, good luck figuring out how to solve your issue.
Yeah.
No, this is interesting. I've got a ton of questions. The first one is, you talked about something you mentioned as you were telling how you got to doing what it's doing now. And that was the pivot from Web3 to creating this build platform. Now, I think it touches on one of the fundamental things of being an innovator in an emerging space, right? The fact that you're working on stuff for which there isn't necessarily a clear path to monetization, as clear as some other things you could be working on. And that's what the job is, right? If you're working on innovation. What can you talk us through? I know you talked a little bit about it, but let's double click on that. The internal dialogue that went on that made you say, okay, I know this is in an emerging tech space, but even for an emerging tech space, this is kind of like the line I've drawn, and I need to move to something more immediate. Still emerging, but like...
Yeah, I was trying to pull up something to actually walk through.
Yeah.
Because it was, okay, so what are we going to do? We're not returning the money back to the investors. We're going to go slay another dragon.
Well, before that, like, how did you get to the point that, okay, Web3, I love you, but, I'm going to go do something.
Very straightforward. You start going to the conferences. Number one, I am not enjoying myself at these conferences. These people are interested in being rich and being rich fast. There's a giant ambition gap. I am not going to change the world with people who are purely financially motivated. They have to be mission aligned. And if you make $1 billion and vanish and we don't achieve the goal, we haven't won. So that's already number one. There's the chasm gap here in vision and mission for the world. Number two, the product that we're building, distribution channel. What is our distribution? The place where a user gets rogged. Maybe they're in a Discord channel, they talk to somebody, they give them their keys, Or, well, actually, where's the place where the thing is literally going to happen? It's inside a wallet. How many wallets truly exist? 5 to 10? So then that means that our only customer is 5 to 10 people. Our entire market is selling to 5 to 10 people who themselves don't even have enough transactions going through every day to really test this thing out. It's very clear that the day is not there yet. Or we have to go write our own wallets and go find people who want to do transactions. If you have to go find people who want to do transactions, that the volume is not overwhelming to be able to support multiple hundreds of wallets, we're not there yet. So that has to die. Now you can pivot into something else within that space, but then pulling metrics, hard metrics every week. How many transactions goes through Ethereum? How many transactions go through this? Mapping that week after week after week after week after week after week after week, and seeing that majority of these transactions are people actually playing some financial game, that these are not services for end users. The metrics don't lie. After pulling them for like 10, 12 weeks straight, and then pulling historical stuff and seeing the trend, you're like, no, it's not there yet. There is no killer applications that end users are just using and they don't even care that it's Web3. The only people really using the stuff are people who really care that it's Web3. And they just don't scale. So that became very, very clear to me that, well, this is the reality of this. We're not going anywhere.
No, it's interesting you said that, because as we were talking, I was trying to compare it to Web 1, right? And so some of the things you mentioned, killer applications, number of transactions, all that stuff. And by transactions, I don't necessarily mean just financial transactions, but like number of actual things happening, right? Yeah, I can see the stark difference. So I guess my question would be, and Zach, I'm interested to hear your take on this, or whatever questions this generates for you. But what do you think is like Web3? And by Web3, I don't mean crypto, right? I just mean like blockchain technologies and all that stuff as well, right? Well, what do you think is needed for it to hit that inflection point and for us to begin to see some of these things like a killer app, more transactions that actually solving a problem and stuff like that? What's needed in the ecosystem, just from your experience working with it?
I think it's not necessarily decentralization. Decentralization is slow. and requires too much buy-in from everybody hosting servers. People are not going to just be hosting servers everywhere. There's a reason why it's not going to be. How many of you, do you know anybody today that is hosting their own email server? You can. It's not that hard, but we don't, because we don't care. We're happy to use somebody else. Gmail hosts my server. I don't care. So decentralization is going to be a big challenge. It's eventually going to end up being like 10, 3, whatever cloud providers hosting all the servers for us. Fine. Full transparency. That's actually what we want, is full transparency. The reason why we think decentralization is great is because it gives us full transparency and also makes it hard to just rug everybody. Like, you can't go find the one boss and take them away. So that part of actually having something that is truly sovereign is going to be hard. We may have to leave that. But I think in average, people don't really truly users don't even care about that. For certain kinds of secure type things, you should still use that. But for every single thing of just, I want to go and buy soda at the end of the block, I don't think you care about sovereignty like that. But you do want to have full transparency over the system, that you can query that system in a human readable format to make it very, very easy for you to like be able to see. You need something like Git. You go to any Git repo. First of all, Git is so powerful and beautiful. You're not locked into any vendor. You don't like this one? Just take your repo and go push somewhere else. It's not locked in anywhere. And the history of every commit is in that one object. And you can just take it with you. There's no problem there. Full transparency. You can see every single person that has ever committed to this thing. And it's done in a way that is human readable. There's an address, a handle that did this. And so it's easy for us to do that. We need something akin to that that makes it very easy to solve those coordinating problems. And then we need it to work in actually deploying applications in a way that is trivial. Very, very trivial. Safe, trivial, at scale. And it probably will be hosted on proprietary clouds. And I don't think people would care, as long as they can just have transparency.
That's a startup idea right there. Zach, I know you have strong thoughts about this topic. What are your thoughts? Like, what does Web3 really need to take off, as it were?
I don't think I have strong thoughts because they're dynamic. They're extremely dynamic because the environment is extremely dynamic and volatile. My thoughts on the Web3 matter changes drastically by the season. I think right now is a good season to reinvest in not figuring out what's the killer use case, because the killer use case for Web3, which kind of, or for crypto / blockchain / Web3, which kind of what made it a biohazard to touch, was that the use case was money. It became that the tokens are, well, they have a parallel in the real world. I think any quote unquote killer use case from Web3 / crypto / blockchain would not have any tether in the real world. And that's a very strong statement. Don't know how I'm gonna be looking back at it. But the idea is you could create value in that parallel universe and that value stays there. And that could potentially create a parallel economy that's purely informational. In practice, it'll be very, very hard to make a transition there. Currently, there is one equivalent to Substack on Web3 called Paragraph.XYZ. There is one social network, maybe two. The one that I'm very familiar with is Farcaster, the distributed social network that's pretty interesting and pretty cool. And all these new actors are trying to figure out use cases, trying to build new concepts and new user experiences and so on to get people to either engage more or spend more time or find value. But at the end of the day, I think it always comes down to, it's a problem that's not being organically surfaced. It's a problem that's almost forced because there is so much VC money in the ecosystem that wants returns and would rather divest in AI, for example, today than stay locked into an industry that potentially doesn't have any returns. Plus, the political climate in the country with the most VCs with regards to crypto is not super friendly. I know there are potentially changes on the horizon, but all in all, it hasn't been an environment that's conducive to either
Experimentation, yeah.
to experimentation, to fair creation, to anything, because it's been like just hammered left and right by everybody, from like taxes on this side, the SEC on that side, and you can't do much. And guess what? That's why you have people doing crypto scams. You can't do a crypto scam in a regulated country like the US, but yes, you can definitely take your business elsewhere and run your crypto scam from whatever island of the day. So on the one hand, I don't have a straightforward answer. What is the, like, what does it take for this space to take off? But I know that what it takes for this space to take off is to weed out the people that should not have been in this space in the first place, and kind of offer them some kind of distraction in the meantime. AI, for example. And so if people that have been focused on making a quick buck on crypto focus a little bit on AI and figure out like what's the opportunity there, maybe actually crypto builders can go back to building on crypto and figure out what are the potential use cases. But at the same time, I don't think it's going to be a utilitarian use case. It's very likely going to be games, for example.
It actually can be a utilitarian use case, because I think the thing that I saw that was most powerful is NFTs. And it goes against Zach's thing, because I think what makes NFTs powerful is tokenizing things that really matter. So things that are purely digital in the way they work anyway, not even real world assets. They
like
are real
they are natively digital.
Content, movies, music, all of these things, they don't exist anymore on anything. They are now software. They are bytes on some server. Your movie, if you're using a digital camera, there is no film, there's no physical anything. It's already living as bytes anyway. So it doesn't matter. Those things should actually be wrapped up in some kind of thing that allows us to manage that intellectual property cleaner. It's already a digital asset. Let's just add something to make it easy to really do intellectual property rights for digital assets. It shouldn't be regular paper stuff. Doesn't make sense. To me, that was a thing that we lost out on with NFTs. Every song, every digital thing should be an NFT. And it should be clear for you to see who owns it, who generated it, who did the first push. It's very clear. This is the person that created the first push. If you said you sampled something, we should be able to easily see that you sampled something, because we'll see that there are overlapping bytes that look identical. Like, these are digital things. They should live in that kind of digital world and be held to that standard. And if a lawyer wants to come in and do a contract, they can have a physical contract, but it's over a digital good. And that's the interface that I think would make the most sense, because the materials are literally digital. So it's easier to track.
I think that's actually interesting, because it still then comes back to the thing you raised earlier, which is what's the interface, right?
Yeah.
So like this managing of digital things, right? Like it's something everybody can relate. Do I need to know that it's NFT underneath and all these,
No,
you know?
But what you need to know is that it's safe and secure. But what we actually need is tracking over servers. And maybe eventually this is what Fimio will end up solving. We start with Python, because ultimately what we're doing is tracking over servers. We are starting with taking your code and deploying it to a server and tracking that whole thing. Then it's what happens when it's inside the server. Usually it's observability and monitoring. You need something that can go from code all the way to the end and tracking over all the multiple servers that it goes to. That's literally what we're talking about. Tell me where everything is. That's literally what we're saying. We just use all these big words, but once you understand what's going on, just tell me where everything is. Give it a key. Tell me everywhere this thing has been. And if somebody copied it, give me the copy. There must be some kind of thing that lets me track the copy. Where is everything? Oh, this is the dupe. This is the original. Just that's what we're talking about here. It may require 1 or 2 PhDs or somebody to just sit down for 2 or 3 years and understand the entire process. But that's what we are talking about. Doesn't need to be sophisticated. It's deep tech. It requires time. It requires some labor. It requires bandwidth of focus. It requires some funding. And then it requires, if we did this, can we sell it? Yes, we can sell it. We can go raise money against it and just do it. It's not going to be sexy. It's not going to be interesting. You're going to be on front page or something. It doesn't matter. But you'll be doing something that is computationally interesting, that solves a real world problem. That is the end of counterfeiting right there. Boom. And so these are the things that I want to inspire people to do. And if you're interested in stuff like this, hit me up. I'm sure I'll find a place for you at Fimio. And then we also need solutions to this kinds of problem because it goes into so many, many ways. Eventually, our electoral systems are going to be digital. So secure confidential computing should just be the standard. It shouldn't just be like some special thing. No, it should just be the standard. You shouldn't have to know. It's just, Git is so secure. Do you ever wonder? Do you ever even think about it? You don't. It's just, we all just use it and we don't think about it. What? Go ahead.
Now that you asked that, I'm thinking in my head like, oh, wait, is it actually secure?
Yes, it is, because if somebody pushes a commit, it is very clear that they pushed the commit. It will be added to the history of that repo. And because it works in a way that is distributed, any other person that has a version of that thing, that's where you have your merge conflicts, your collisions. Yes. It is clear that something has changed here. And because it's clear that something has changed, means it's secure. So what is security is, I just want to know if something has happened without me knowing. And once there's full transparency equals security, because you know when something has been tampered with.
And who can I blame?
Well,
for it.
Who can I blame for the right thing?
Oh, man. Okay. This has been amazing. I'm going to start bringing it to a close. Zach, feel free to interrupt if you still have stuff on your mind.
I was going to open it to even more. Like you said,
oh, my God. Okay. I don't know how much you
Maybe
tell
we
me.
can have series of
series,
Abby,
of
because
this.
I'm interested in this too. Like, we've all been nerd snipe. It's like fascinating.
No, for real.
One last question that I had was more on the kind of the meta side of what Fimio is doing right now, because I think there's definitely a lot of parallels between what Git as technology does for software, or did for the software industry, and how we can port the same idea elsewhere. And what Fimio is doing is kind of like port the idea elsewhere, but it's still close enough to the domain space that it's not disruptive enough.
No.
And so kind of, what's your ultimate disruptive model? Because I know there is blockchainization of the word as the kind of the ultimate goal.
So my ultimate moonshot.
What would, where do you see Fimio 5 years from now?
Oh, okay.
Or 10 years from now, assuming
Zach,
everything
I have
goes
ambition. I have ambition.
I know.
That's why you're on the podcast.
I want to hear what Git for everything looks like.
Okay, so we're starting with Python. We do all that one. Then we get to the point where we can really do it very well on all servers. But more importantly, the thing that we've never mentioned in all this, we're doing reproducible builds. You're building on what? Compute. This build is happening on a machine, a powerful machine, especially for ML. It's compute. So inference is, everything is we're talking about is compute. And that is a problem. Large language model training. Maybe they need 10,000 GPUs. Who can afford that? Maybe 10. Doesn't make sense. It's way beyond our reach. But fundamentally, is it though? If you take it back to first principles. So I was thinking the other day, this is my one house. All these things that can do, remember I said it's multiplication and addition. So let's just get it to its most basic thing. We are doing multiplication, addition, and subtraction. That is what we are doing. We're just doing it over and over again. Very, very big numbers. I have my cell phone. I have my laptop. I have all this old iPad that I bought that I forgot I even own. They're there. All of these things have chip. I have a Tesla. The other day, I sounded so stupid. I've had this car for 2 years. I thought the car turned off. I don't know why my brain just did not add two and two together. I know this car updates itself all the time, but somewhere in my brain, I still felt like it turned off and turned back on. And I usually park my car in the garage, but I decided to park my car in the driveway, and it was super hot. And then I realized that water was coming out of the car, but I didn't connect anything. It was doing AC. And then I go to turn the car on. The car is not working. It's not talking. It's not doing anything. I say, this car is dead. It's dead. How can it die? I call the Tesla people. They say, the car is on every time. I say, what do you mean the car is on all the time? They were like, yeah, the car does not turn off. It's constantly on. It's a machine. It's just a computer that is always
a computer,
live.
like a phone.
And that, has it been in the sun? I say, yes. And it's been doing AC that the battery don't knock. I said, what do you mean the battery has knocked? I thought it was an electric battery. They were like, yes, there's a regular battery in front of the electric battery to prevent people like you from draining the thing to death. I was like, oh, snap. Okay. Information. That car is a computer. Why is it just doing nothing for 97% of the time? I barely drive. I'm going to like 5 miles radius. So I have this powerful computer that is doing absolutely nothing. And I'm not the only ones. Everybody has this computer. Why can't we just bring all these computers online? They're just a giant cloud. We have decentralized technologies. That'll be my ultimate goal. Just have an agent that runs the background in all these things. And we can have as much power as we want. Some things might not be as fast. Some things will be slow. So I want that. I want to just connect everything and use it
What, like
for compute.
you oh my goodness. So I was gonna mention this. So it's something I've always thought about, but I thought it was crazy because I didn't know enough to know if it was real, right? But I was gonna bring it up. Everything you said, like cell phones, and for me, I think that's like the perfect intersection of Web3, AI. Even there's something I've been looking into now, analog computing.
Yeah.
Because we're talking about like, Zuckerberg was saying how you probably need like a nuclear reactor to power the level of compute that's needed to do all the stuff they want to do. And I'm asking myself, does that have to be the case?
I don't think it actually has to be the case because I've been thinking about it. I think one GPU, don't quote me, I think one GPU is like 10,000 CPUs or something. Like in parallel, those people did some kind of thing. Okay, maybe if it's 10,000 to 1. So then 10,000 times 10,000, whatever, there's a number, right?
Yeah.
Do you know how many devices are on Earth? A lot.
A lot. That are idle most of the time, to your point.
Most of the time they are idle. They're not doing anything. People who are already doing large language model training are already scheduling time on some cluster and waiting for their turn. So they're already used to doing it. They don't do everything fast anyway. What if you have to wait 3 months to get the answer? Does it matter? Because we're not talking about inference. We're talking about training.
Yeah.
We actually have so much compute. It's the way we unlock those compute and use it for our ends and bring all the solution back together. But we already have distributed systems that can do this. We just need the ambition and the money to do it. And then on top of that, I would also want to go after the big boys. It should be Fimio, AWS, Azure, and GCP. And I want to do Fimio as let's just do one thing. All these 10,000 things inside this giant cloud, half the time we don't need this. Can we just do something that's just compute? And let's not wander all over the place. Just do one thing, do it very well, do it at scale.
Consider me an advocate. Consider me what do you want to call it? Disciple, advocate, whatever it is of that idea. I'm really bullish about that. Have been for many years now. Yeah.
We wrote it into our roadmap and we're like, okay, so this roadmap that I've written is 10 years long. Let's just focus on the first 2 years. Forget all these other ones. So we actually have all these things written into our roadmap. And then beyond
that's what deep tech is, right?
Yeah. Beyond that, I have a goal that when we get to that point, I want us as humanity to give away 1 hour of global compute to a problem that we think is worth giving it to. Maybe you want to do some kind of ridiculous level search for life in some outer planet somewhere, and you need a massive cluster of clusters. We should just donate 1 hour of that global compute to do that kind of search. That we all know as humanity, these 59 minutes on this day, we've all voted throughout the year. And we're all just there watching. It's on Times Square. It's in London. It's on the Sphere in Las Vegas. And we're just watching this machine go chaka, 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 chaka. We're drinking beer. We're doing everything. And we find the answer. We're like, yay! And then we have to vote again till next year on what we're going to run the compute against. So all of us in our own little way, whether it's your little Nokia phone or your iPhone, everything is contributing something. Even down to human computers. Human beings that just want to be doing 1 + 1 and uploading their answer somewhere. All of that is compute. We just get so sophisticated, you don't understand what compute is. It's anything that can actually do computation. It doesn't have to be digital. What we care about is the answer. And this is the best thing we know right now. In the future, it will be quantum. It doesn't matter. Just put everything together, do it faster, let's be done. It's just the ambition gap, and actually also people understanding in a very practical way what these things mean. Because these words can sound so big and you're so like confused and you just feel overwhelmed and stupid. But once you really understand what things are, you can start reasoning your solutions in your head and be like, okay, I can do this, I can do that. You start doing tiny little prototypes. They may go nowhere, but it doesn't even matter. It gives you way more knowledge. And you're just like, and especially us Africans, we should know better. Nigeria is one of the few countries that you really understand what the internet is. That all that stuff they were trying to do in Lekki, that they canceled out this bridge they wanted to build because they felt that they were going to break an underwater sea cable for the internet. For us, it's very real. We see that, there is a tunnel somewhere with fibers in it. That's the internet. I think people don't know enough about how the internet actually is a real thing. And that's why they don't understand what these things are.
Whole other conversation. Whole other 10 conversations.
Because it's not magic, it's real. It's something
10
somewhere.
conversations.
It's electricity. So I'm going to write a book about reproducible builds. That's something I owe everybody. I'm writing a book. And I write the book in a way that is technically dense and sound, but understandable for anybody. So that if you go through the book, you actually understand what I'm talking about. And with the assumption you know nothing. Take you from I know nothing to, hey, I can have a conversation about a reproducible build. I'm going to write the book.
You heard it here first, folks.
And we'll put a link, if there's a link, in
Yeah,
the description box.
We don't have the book yet. I say I'm going to write the book, Zach.
You can start an email list to start collecting people who are interested.
Exactly.
Reproducible builds.
No, but and I'll tell you, like this whole moonshot that you talked about, like I said, like I've been thinking the same. I know at least 2 other people who like have been thinking like if you want to use that as
because there's
like you're not crazy, like
new. It's not even new. Folding at home does this. The protein folding at home, they do this all the time. And they do it and they actually solve some problems. SETI does this, search for extraterrestrial life. They do this. So this is not fundamentally new, but it's the scale and the agents to unlock. It's unlocking old compute. Like making sure that we can work at what level do you want to go down? How do we actually jailbreak Tesla? Maybe we don't need to jailbreak Tesla. Maybe there's a mode in Tesla that allows you to just access the compute. Maybe we can go talk to the Tesla people and be like, yo, can we do this? Can we do that? It's those small little conversations and putting your devices together on a on a network and being able to submit jobs to them and get jobs from them. The thing that will allow that to occur already exists on IPFS, Bacalao project. Like it already exists now. It's just now the hardware part of like, hey, here's my old iPad. Can I actually access the
how do I
CPU?
plug it in?
Oh no, Apple has locked something. Okay, can we go talk to them? It's just that's the issue. Now. Make sure you can actually access that chip on that machine and send directions to it and get directions back. Directives to it. Half the people don't want you to touch it.
Yeah. But that's what Zach, you were lying when you said this is a whole new direction. But so that's what the agent would be doing, right? And
because your TV is a smart TV. The TV is literally a computer. All this fridge that do too much. The washing machine that is telling you that it's time to come out. All of these have chips on them, but they do
they're powered.
They're powered and they do only one thing, and they barely do it for like 2 minutes.
So you could have a thing where you have this ecosystem of people who specialize in building agents for whatever platform they care about, and contributed back to the whole.
Yeah, like here's the agent for the Miller washing machine. Here's the agent for your coffee maker. Here's the agent for your. And then you can see how Hollywood can turn that into a nightmare dream where you hijack the
Right.
whole house.
Hijack the whole house.
But if you make a reproducible build that is a secure build environment, we can. That is why this is why you need reproducible builds. It is impossible.
Actually, you're touching down on a very important point that I completely missed. I was thinking earlier about this startup that just raised like an ungodly amount of money, $300 million, Series A. It's called Skilled AI. They're building brains for robots. And I was thinking, wow, actually, like the Fimio tech can definitely be used to deploy, code on these robots. Like
Oh
if
yes,
you're building,
yes.
because the robot basically becomes an IoT
It's a server.
Yes.
Yeah.
And like everyone is running around like trying to prevent AGI or ASI or like rogue super intelligence and whatnot. I'm like, well, one way to actually prevent rogue super intelligence is
Secure
like
builds.
secure
Reproducible builds.
Reproducible
It's so
builds.
simple.
Exactly. Yes.
This is why I'm going to continue working on this thing and make it so simple and trivial on every environment. So our next thing, which is, and I know I should stop building and start selling, but it's almost like crack. You can't stop. I want to deploy Fimio on a super cluster. So to just have it work at the cluster level, that's also part of the roadmap. And thankfully, I'm a cow bear, go Bears. We have a cluster over there. Somehow we're going to deploy Fimio on that cluster and just make sure that it works. Maybe that'll be an internship project for some researcher next year, Let's get that working because this is what we need to do. If you can have fully reproducible builds and make those builds good user interface, good UX, we have really closed off a lot of our attack vectors. Not all of them, but at least we've closed a significant chunk of them.
How Fimio
Interesting.
saved the world.
Hey.
You heard this here first.
Right?
Fimio saves the world.
Oh, okay. So one thing we've concluded is we're gonna have another one. And when you're coming back.
Oh, I'm
But
coming
before-
back. I can be the friend of the ADTC podcast because there's so much
Let's
for us
do
to
it.
talk about.
Man, for real. So I'll close us out with hopefully close us out. This doesn't lead us in another whole
No,
new
I need to
direction.
go and
But
cook stew.
we-
I'm hungry.
Okay, great. So a thought that you leave us with, before you go make that awesome stew. So we've been talking about this stuff. There's a bunch of Africans or people of African, descent who are going to be watching this podcast. So where is Africa's place in this whole thing?
Okay,
It-
this is
like-
another conversation. But
Yeah.
Africa plays a very important role.
Yes.
Africans, please pay attention. Depose your bad governors and governments and presidents and get serious people in charge of our countries. Everybody needs raw materials, lithium. Where are they going to collect all these things that they need to power everything? It's in Africa. I don't know about the rest of Africa. I know it is in Nigeria and it's in plenty. We have so much lithium, it's ungodly. We are literally the thing that makes the thing go. But we have chronic bad governance that is holding us back, number one. Number two, we have people in spades. And we have people that are, Africans would get, if there's 10 PhDs to be gotten by somebody, to be an African, that would get 10 PhDs. So we have the brain power, we have the numbers, we literally have the sheer raw numbers. We have the human capital, we literally have the raw capital, the raw materials and human capital. That is a dynamic duo. If we get governance together, lights out. And on top of that, we have a distribution channel. It's called Nigerians. They're everywhere. They're everywhere. You don't need to do anything. Just have one Nigerian friend. You'll need something to go to Russia. They will get it to Russia on WhatsApp in 5 minutes. They have an uncle somewhere in Siberia. We already have distribution channel. Nigerians. You just need good governance. Good governance. That's
I
it.
never thought about myself as a distribution channel, but
Emeka, you are.
I'm wiser now.
Yes, you are. That's why we are ruling everything in terms of culture. It's very cheap and it's very easy. A Nigerian movie that is good, everybody tells their friend on WhatsApp, it'll be number one all over the world. Because they're literally everywhere. So these are all the things that we are not understanding yet, that we're just slowly waking up to. And so that's where Africans come in. Good governance, that's all we need is good governance and people willing to actually go into solving real problems and going into hard tech. It's not everyday fintech. Do something else.
So yes, Okay, I promise this is the last question. So you spoke about Africa from a macro perspective. So let's talk about micro to the individual, right? So you say it's not everyday fintech or going to deep tech or hard tech or whatever it is. What is that for somebody who is an Android developer or I'm your everyday web backend developer, and I watch this podcast and I'm like, oh my God, all this stuff is exciting. I need to pivot and get into more
Go
deep
into
tech
open
based stuff.
source. You're already technical, go into open source. So the things we're talking about, are there any repos out there that are building agents that can work on these different platforms? Or just start asking yourself the right question. Okay, I'm an Android developer. If I wanted this phone to be used as a computing platform, what do I actually need to do to actually get access to the chips on my phone? Can I do 10 times 2 and have it work on the computer on my phone? And is that interface open? Can I deploy something to it that is outside of the Android build system? What is just start asking yourself all those questions. Android has like Gradle build. Like if I wanted to build something that doesn't fit this, where does it stop? And just start pushing to the point of Python wants to do, I will have a Python script that does this metric multiplication. And I want to use the chip on this Android computer to do it. How am I going to build that? That's the Android person. Every single person that is technical has some kind of thing that they can push towards. It may be a Raspberry Pi. It might be I do front end. Okay, is there some kind of compute or cache on a web browser? Just start asking this different, try to know how the thing becomes the thing. Like what, all the different things. And once you do that, then you understand, okay, this is where the compute is coming from. How does this web browser actually work when I'm offline? How does it connect to the battery system? What does it mean that the CPU has taken up all this information and is this web browser? What is eating up the CPU? What are the processes? Just be curious. Whatever it is you do, keep asking the questions all the way till you get to the compute, because everything is powered by something. And what is that interface? We need access to that interface and make that interface open, and we can track it to be able to make our dreams come true.
So many nuggets in this conversation. Man, okay. So Omoju is coming back.
Yes.
This has been awesome. Yeah, like Zach, we may need to even like this particular episode may need even to be two videos so that we don't cut anything out. just say it. But
Well,
yeah,
with our army.
I'm telling you, man. Well, yeah, thank you so much, Omoju. Like, this has been wholesome, and like I said, just hanging out with you, I get smarter, even if nothing is said. How much more for the conversation? I don't know, Zach, any parting words?
5 IQ points.
Right? Oh, man.
This was
Yeah.
great. This was great. Can't wait to have another deeper dive. We barely scratched the surface. Thank you for making the time. Thank you for coming. Thank you for everyone watching. See you next time.
Thank you, everybody. And thank you all
Thank
for
you.
having me.